Hi, and welcome to 10.3 Notes. We're talking about angles of a triangle. In words, the sum of the measure of the angles of a triangle is 180 degrees. In symbols, that would be written each angle. Here we have angle x degrees, y degrees, z degrees. Each angle adds up to equal 180. The sum of the angles of a triangle equals 180 degrees. Let me show you with an example problem how you will use this. For example 1a, there's not a picture of this triangle. There's some triangle named DEF, and we're going to look for the measure of angle E. The measure of angle D is 62. The measure of angle F is 39. So this can be my X, this can be my Y, and this can be my Z in the formula here. So I'll say X plus 62 plus 39. And I know that all three angles should add up to equal 180 degrees. So X plus 101 equals 180 degrees. Subtract 101 and X equals 79 degrees. Okay, for our next example, alright, so using our picture provided for our second example, they're asking us to find X. So we'll let this be Y and Z. So X plus Y plus Z adds up to equal 180 degrees. So X plus 33 plus 100 equals 180 degrees. 133. Subtract 133 from both sides. And X equals 47 degrees. Okay, so that is a formula that you need to remember for all the angles of a triangle add up to equal 180 degrees. Now, the next portion of our notes you need to become very familiar with. It's called classifying triangles. The first side is using their angles. If all of the angles are less than 90 degrees, so to be acute, an acute angle measures, that's an abbreviation for angle, measures less than 90 degrees. So all of these angles are less than 90, makes this called an acute triangle. To be an obtuse angle, it measures more than 90 degrees. So again, this is the abbreviation for the word angle, and that means it measures more than 90. Well, since all the angles add up to be 180, I cannot have two angles that are more than 90 degrees, because think about it, 90 plus 90 is 180 degrees. So if I have two angles that are more than 90, then I've already used up my 180 degrees. I don't have anything left for my third angle. So to be an obtuse triangle, you have exactly one obtuse angle. Now notice we had three acute angles, but here we have one obtuse angle. And then of course, to be a right angle, it means that it equals exactly 90 degrees. It's equal to 90. And here it is. The box represents 90 degrees. So whenever you have a right angle, we call that a right triangle. The right side of this chart is classifying triangles using their sides. Scaling. Scaling means no sides are congruent. Notice there's not any little tick marks. The tick marks here mean that this side is equal to that side. So if there are at least two sides congruent, that's what the tick marks mean. They're congruent or equal. Congruent is another word for equal. Then we call it an isosceles triangle. If we have three sides equal, all sides congruent, we call that an equilateral triangle. So come back to the first picture where there was no tick marks, no sides are congruent, so it gets this funny word, scalene triangle. So you need to get yourself familiar with these terms so that you can identify these different triangles. Let me give you an example. Classify each triangle by the angles and the sides. Alright, well my very first problem here, I do not know my missing angle. So the first thing I have to do is do the math. 58 plus 73 plus x should add up to be 180. And as you get good at this, the more you do it, the faster you will get. So we find out that this angle here is 49 degrees. None of my angles are greater than 90, so we call this a cute little triangle with no angles greater than 90 or equal to 90. And that's by its angles, but it also says and by sides. So since none of my angles are equal, none of my sides are equal, so it would be acute scalene. Our next picture has two tick marks. By the way, that's already, I know, isosceles. Two sides, at least two sides are equal. And if two sides are equal, I want you all to also understand that that means these two angles have to be equal. But if you didn't think of that, the fact that two sides are equal, the two angles will be equal, go ahead and say 180 total degrees. We know we've used up 90 degrees with our right angle, so we have 90 degrees left. We've used up 45 degrees of our 90 degrees that was left, so we have 45 degrees left here. So because we had a right triangle, actually we didn't even need to know x. We could have said it was right isosceles before we found x. But now you see how quickly you can find x once you know to take out the 90 and then take out the 45. You have 45 degrees left. But because of the right angle and the equal sides, we call it right isosceles. Okay, our next picture, I see an angle that is 107 that is greater than 90. So I know by angles it's going to be obtuse. Let's make sure that it's not isosceles, because if this angle was 36, then it would be isosceles. So again, 107 plus 36 plus x should all add up to be 180. 143 plus what number equals 180? Subtract 143, and x equals 37. Okay, so it's obtuse and scalene. No sides are equal. It was close to 36, but not quite. Alright, all sides are equal, so we call that equilateral. Excuse me, equilateral, maybe it's an I right there. Equilateral, and all the angles are equal, so what's 360 divided by 3? 60 degrees, so this last angle must be 60 degrees also, and those are all less than 180, or excuse me, less than 90, so it is acute equilateral. I'm going to leave the last two for you to do, and we can check those together in class on Wednesday. All right, good luck and have a great day.